All right, here are the solutions for review assignment number 2. We're going to do this on a separate piece of paper, but here we'll read it first here. A particle moves along the x-axis so that its velocity at any time when t is greater than or equal to 0 is given by this equation. The position is 5 when the time is 2. So first, write a polynomial expression for the position of the particle. So if you know the velocity, how do you find the position? We integrate it. So let's start there. So take a piece of paper out. Write down review assignment number 2, number 1, A. That's what we're doing. And as always, it's best if you do it first. See if I can get this thing cleared up. So the velocity is 3t squared minus 2t minus 1. So to find the position, we're going to integrate the velocity. So we're just going to add 1 and then divide. So if I add 1 to the exponent and divide, the 3's divide out. Add 1 to the exponent and divide, the 2's divide out. And then negative 1 would just be negative t plus c. Then we need to understand the position. So the position is 5. So I'm going to make the position equal to 5 when t is 2. And you get to use a calculator here if you need it. So then I'm going to solve for c. This is 8, take away 4, take away 2, subtract, and I get c is equal to 3. So altogether, the position of it would be t cubed, subtract t squared, subtract t plus 3. Part B. For what values of t is the instantaneous? So what does the word instantaneous mean? It means derivative, right? That's what the word instantaneous means. The same as its average value. So the average velocity is going to be like y2 minus y1 over x2 minus x1. Again, we're going to use a calculator if we need to. So the instantaneous velocity So we're going to take the velocity equation and make it equal to the average one, y2 minus y1. So I need to know the velocity at 3. I need to know the velocity at 0. So if I plug in 3, that's 3 times 3 squared minus 2 times 3 minus 1. Not too bad yet. So that's 27, take away 6, take away 1. I think that number is 20. Make sure. Oh no, the average, calculus. Let's do it right. Boo. So the average velocity is an integration question. So from 0 to 3, and then 3 take away 0. So you integrate from 0 to 3 the velocity, which is up here, and then divide by 3. That's an average value question. Let's see if we can just put it in our calculator. So I'm going to go menu algebra, and I'm going to solve this. I can use 3, so 3t squared minus 2t, subtract 1, equals. I'm going to do control divide, and then in the numerator, I'm going to do integration. And I'm going to integrate from 0 to 3. And again, I'm going to type in the velocity, what I just did, 3t squared, subtract 2t, subtract 1, And then in the denominator is 3 take away 0, which is just equal to 3. And then I'm going to do comma t, and I'm going to hope this just solves it in one step. Let's see. So I get negative 1.1, but we said t is greater than or equal to 0, so it can't be that one. And I got 1.786, which is perfect. That is the answer. And I'm telling you, if you can use your calculator, we're going to set it up and then just use your calculator to answer it. Beautiful. Part C. Find the total distance traveled by the particle from 0 to 3. Now, the word total distance means the distance to the right and the distance to the left. So what I'm going to do first is going to see, does the particle change direction? So I'm going to factor it. Now, I'm going to let this factor it. Why not? So I'm going to go menu algebra. Well, actually, I'm going to solve it. So let's just solve it. And now I'm going to type that in. 3t squared, subtract 2t, take away 1, equal to 0. Comma t. So we got negative 1/3 and 1. Well, t can't be negative, so it can just be the positive 1. And it's going from 0 to 3. And then if I plug in 1/2 into here, is it going to be positive or negative? Or if I plug in 2? In fact, I'm going to plug in here. So I know that if it's negative 1/3, this is like t plus 1/3, and the second one would be like t minus 1. So if I kind of work backwards, those two answers. So if I plug in 1/2, it's a positive times a negative, which is negative. If I go the other way, if I plug in 2, it's a positive times a positive, which is positive. All right, so it does change direction. So to know the total distance, I need to figure that out. Now, we could also, that's true, we could also actually integrate it and do the absolute value. So I'll show you two different ways you can do it. So one is I want to know the distance from 1 to 0, and I want to know the distance from 3 to 1. And then I'm going to add those two together. So if I find this distance and this distance, I can add it up. And then I'm going to show you a shorter way. So I'm going to show you different ways we can do with our calculator, and hopefully you're a good listener. So first of all, to make my life a little easier, I still have this from the last one. So I'm gonna delete it all, and I'm just gonna plug in 3, and I can use t. I'm gonna use x. So 3x squared minus 2x subtract 1. I just want to define it in my calculator, and that's it. And I'm gonna go back here because then I can just go f at 1 subtract f at 0. And then it would just calculate it for me. Oh, what happened here? Oh, I know I did wrong. Was it F1? Look, make sure. Press tab. It's F1. So I got to type it in right. So let's do it again. So it's F1. So F1 at 1 subtract F1 at 0. And I get the answer 1. Oh, wait a second. I'm using the wrong equation. So to use it, I'd actually have to use this equation. That's the position equation. Let's try it again. Then I'll show you a different way. So tab, it's okay. We're learning through this. So I'm going to change this to 3x. It's going to be cubed. So it's going to be just x cubed, subtract, and I'm going to show you a quicker way. X squared, subtract x plus 3. That's what we did for part A. All right. Perfect. And then I'm going to go back here, and then I'm going to recalculate this. So now I recalculate it, and it's -1, but we're going to write it as a positive value. So it is 1. Then I'm going to do the same thing, but this time I'm going to use 3 and 1. So I'm going to write F1 at 3, subtract F1 at 1, and that distance is 16. And then if I add it up, the total distance then is 17. Here's another way we could have done it. Another definition of total distance is to integrate from 0 to 3 the absolute value of the velocity. So if I can remember that total distance is the absolute value of the velocity from 0 to 3, I could have done it in one step. So if I integrated from 0 to 3 the absolute value, so the bars here, press the button beside the number 9, and then go absolute value, and then type in the velocity. So it is the velocity, 3t squared, subtract 2t, subtract 1, and then press enter. You'll see you get the same answer. Get that reflection off there. You get 17 both ways. So there are two different ways to get it, and the answer is 17. All right, that was number 1. Number 2. A particle moves along the x-axis from 0 to 16, and it's given here. E to the 2 sine t subtract 1. And at time equals 0, the particle is at the origin. Sketch the graph of the velocity from 0 to 16. So I'm going to sketch here. I'm going to change the window in a second. I'll show you how I'm going to do it. So first I'm going to type this in. Sorry about the shine. I'm trying to figure out here. If I move it a little bit left, I think it's a little better. Okay. So I'm going to type in E. That's the E on the left, not on the keyboard on the bottom. And then 2 sine, so go trig. Again, we're going to use x, because if I do t, it's not going to graph it. Subtract 1, so move the cursor, so it goes subtract 1. Then I'm going to change the window. So I'm going to go menu, then window. And I'll change the settings here. So we know we're going to go 0 to 16. So we're going to go 0 to 16. And then I'm going to go from like -2, I don't know what it'll be, up to 6, let's say. I don't know. So 6 doesn't quite give me enough, but you get the idea of what the graph looks like. So go menu, window, window settings. Again, I just need to change that 6 maybe to like a 10. Again, it's just a sketch. Make sure you see the important parts so you get a sense of what it looks like, right, from 0 to 16. So if I sketch this one, this is number 2A. That's kind of how the sketch would look. It's not very, you probably could draw it nicer. So again, you're just redrawing this right here from 0 to 16 here. And so you can see when the velocity is above, it's going to the right, and when the velocity is below, it's going to the left. And then it says, during what intervals is the particle moving left? So to understand when it's moving left, you have to know when it's below the axis. So I'm going to go menu, analyze, and I'm going to find the zeros here. I want to know the x-intercepts. So I need to know this one. I'm sorry again about this. I'll try to do that. So I'm going to press enter. Again, I use zeros and do that. So we got 3.141. We don't have to round. 3.141. Then we'll do it again. So let's see if it clears up. Menu, analyze, 0. Again, I'm moving it anywhere to the left, press down, and then to the right, press down until you do it. So the next 0 is at 3.141. Oh, we just did that one. Let's do the next one. Oh, I think there's 2 there, and I'm like seeing, I'm not here. So I'm going to grab this one, and I'm going to move it so I can see the next one. There we go. So the next one is 6.283. So from 3.1 to like 6.2, this part right here underneath, it's moving to the left because it's below. And we'll give that reason in a moment. I need to know and keep going across. So again, I'm going to grab this, press down, and then I'm going to move it so the next time it won't be in the way. So again, I'm going to go menu, I'm going to go analyze, I'm going to go 0. And again, the next one is 9.424. I go again. Again, I'm going to take this, I'm going to move it. Okay, menu, analyze, 0. We're almost there. So it goes to 12.566. We actually have one more at the end. So let me move this one here. So when is it moving to the left again? So press menu, go analyze and 0. See if we can find the last one. It's right at the end here. See that one there? That's 15.707. So 15.707 to 16. So we know the velocity is less than 0. That means it's moving to the left. So that is the reason. So in these intervals, it's less than 0, and that's when the particle is moving to the left. Part C. Find the total distance traveled by the particle from 0 to 4. So we're going to use that formula for sure here. So 0 to 4, absolute value of the velocity. Let's do that. One step. So again, we're going to go menu. We can do here. It's another way. Menu, calculus, integrate. You can do it that way too. Again, we're going to go from 0 to 4. Absolute value. And then we'll type in e to the 2 sine. We can use t here. You don't have to. You could use x and get the same answer. Subtract 1. And then whatever variable you used, if you use t, use t. And I get 10.5, double checking, 10.542. Perfect. So this is definitely quicker to find the total distance, the absolute value of the velocity, something to remember. Part D. Is there any, I guess technically this is 3 on there, just so you know. Part D, is there any time from 0 to 16 in which the particle returns to the origin? And justify your answer. So if I look here and understand the graph that I did, so this particle starts at the origin. Everything, all the area above is moving to the right. And the more area above, the more it moves to the right. So it moves to the right. And then look at the area below. See how much smaller it is? And so it's going to the left, but not as far as it went to the right. And then, woo, it goes way to the right, and a little bit left, and then way to the right. It never returns to the origin because the area above is greater than the area below at each interval. All right, next one. This one's no calculator, so I'm putting it away. Number 2, from 1983. I was alive then, but I wasn't doing calculus in 1983, just want to let you know. I could have done it. I was smart enough, but just didn't do it. A particle moves along the x-axis again. It's going left and right. Here's the position of it. What is the velocity at 0? All right, some of this stuff should feel comfortable, I hope. So here's the position. And the question is, how do I find velocity? And the answer is, take the derivative. So we're going to take the derivative to find the velocity. That's 3t squared minus 12t plus 9. And then at 0, what's the answer? And the answer is 9. Part B. Some questions are that simple on the AP exam. They're not all high-level questions. Part B. During what time intervals is the particle moving to the left? So, to understand that, you take the velocity, make it equal to 0, and solve it. So I'm going to divide everything by 3. And then when I factor it, I got t minus 1. I got t minus 3. So at 1 and 3, so at 1 and 3, this is when the particle's resting, where we could change what direction it's going. So from 0 to 1, if I plug in 1/2, I get a negative times a negative. And then the multiplicity means it's going to change signs all the way across. And then the question is, during what time is the particle moving left? Right here, right? So from 1 to 3, it's moving to the left. All right, part C. What is the total distance traveled by the particle from 0 to 2? So, what do we say here? I almost threw that one away. Without a calculator, we need to understand this is going to be easier than the absolute value part. So this is what I'm going to do. I'm going to plug in from 1 to 0 and from 2 to 1, and then write down the positive values, and I'm going to add it up. So S at 1 is 1 take away 6 plus 9 plus 11. 21 take away 6, that's 15, right? Then, from 2 to 1, I know at 0, the answer is 11. So I'm going to go 15 take away 11. So that answer is 4. So I already know S at 1 I said is 15. The only one here, 2, I need to figure out. So that's 2 cubed minus 6 times t squared plus 9 times 2 plus 11. That's 8. That's 24. 18. That's 11. What is that? 29 and 8. I get 13. All right, so 15 take away 13, or 13 take away 15. So the absolute value of that is just 2. So if I add that up, I get the answer of 6. And that's the total distance. All right, I'm going to do another video of the second part. Mr. G Math, over now.